Hi, we're Maddie and Nico, and we are turning this empty cargo van into this tiny home on wheels. We have no building experience, but we'll take you along each step as we transform our 2020 Ford Transit van. Hi everybody, welcome to our pre-wiring video. I'm gonna jump right in and explain how to calculate the size of your wires, because before you can begin pre-wiring, you need to buy a bunch of wire and you gotta get the right size. If you have an undersized wire, you can start an electrical fire, and no one wants that happening in their van, and you don't want your wires getting hot, so this is an important step. So here's how we calculate that. We are going over to a wire size calculator now. This one is from Far Out Ride. Here are the couple things that you need to input into the calculator. You'll need to know the circuit, which in this case, all of the stuff in our van is 12 volt. You could also do 24 volt, but for simplicity's sake, we're sticking to 12, and that's what we used in our van. So the load is gonna be your device that is drawing power. So in this example, we'll use the Max Air fan. If you look at the manual, it will usually tell you the load that something draws in either watts or amps. In the case of the Max Air fan, I looked at the manual, it says it draws 60 watts of power maximum. Okay, great, so you know what wattage it is. Now you gotta convert it into amps. To do that, there is a very simple equation. I'm not the best at math, but I can do this equation, which is watts equals amps times volts. Our watts we know is 60 watts, and then we know we're using a 12 volt system. So if we take 60 and we divide it by 12, we get 5. That is our amps for the Max Air fan. So I'll enter 5 amps here into the calculator. And the next step is to enter your wire length, which is gonna be the total of both your positive and negative wire length. So when you get duplex wire, there are 2 wires in there, and one is for your positive, one is for your negative. So when you are calculating the distance between your battery bank or your fuse panel and your device, you're gonna wanna double that. So for example, with the fan, we estimated that it was about 15 feet between our fuse panel and where the fan is. So because we need to calculate both the distance of the positive and the negative wire run, we just double it. So 15 times 2 is 30. So 30 feet is our total wire length. If you just picture wires as a circle of positive and negative with your device and your batteries in between, that kind of gives you the better visual of why we're doing things this way. Next up is voltage drop. 3% is a very conservative voltage drop. We usually bring this up to 5%. Basically, what happens with voltage drop is that as power is moving through a wire between your battery and your device, some of that power is lost along the way. So even though you have 12 volts starting at your battery, if it's a really long wire run, you might have more like 11.5 volts or 11 volts at the end. Some devices need the full 12 volts of power to operate properly. A good example is our diesel heater. It needs a lot of power at startup, and it needs that full voltage from the battery bank. 5% is the percentage of a voltage that is lost as the power travels through a wire. And so we can stick with that. That's a good amount. If you want to be more conservative, you can keep that at 3%. The next thing this calculator will tell you is your fuse size, which in the case of the Max Air fan is 7.5 amps. If your manual tells you a different amperage for your fuse, like if the Max Air fan manual says to use a 5 amp fuse for whatever reason, then you should listen to the manual. But if the manual doesn't tell you, then this calculator is great and it'll tell you exactly what that is. If your manual doesn't tell you the wattage or amperage of a device, you could just go off of the fuse size. So if it just tells you it needs a 7.5 fuse, you can click this at the top. It says, I don't know the load current, but I know the fuse size. And then you could change this to fuse size and you would put in 7.5 in that case. There are a number of derating factors that you could check, like if the wire isn't, this one's automatically checked for you, if it's in an ambient temperature of 50 degrees or more, and if the load will run continuously for 20 minutes or more, and if it's in conduit or insulation, which in our case it is, although our ambient temperature, it varies. It's unlikely that our ambient temperature will be 50 degrees or hotter, but since we are in a van that could be sitting in the sun sometimes, we can just leave that box checked. So then it says our recommended wire gauge size is 14 gauge wire. And that is the wire gauge size that we used for most of our loads in our van. I will say that for our heater, we use 10 gauge wire, so it is a bit of a bigger wire. And then of course for the other components of the electrical system, which we'll get into later, we also used very large wire for our DC to DC charger. So that's pretty much everything you need to know about calculating your wire size. I will put in the description below a table that I made with all of our devices in our van and the loads, so you can use that same table and enter in your devices. You can enter either the watts or the amps and it'll calculate vice versa basically. Then use this calculator, which will also be down below, but let's get into the video. Today we are starting our pre-wiring in the van. We've done a lot of research this past week about wire gauge sizing and where we want everything to be in our van, so that way we could start our pre-wiring before we go ahead and build cabinets and that sort of thing next. So the wire we're using today is marine grade stranded duplex wire. It is 14-2 wire, which means the gauge is 14, so that's the size of the wire. We were doing our wire sizing and a lot of our calculations were coming out to 16 gauge, which is actually smaller than 14 gauge. That's how American wire gauge sizes work. It's a larger number, it's a smaller gauge wire. So anyways, we were doing our calculations, and although a lot of them were 16 gauge, we had a few that were 14 gauge wire. So we decided it would make more sense financially to just size up to 14 gauge. It doesn't hurt to have a larger wire size. It's actually a bit safer if you do kind of round up in these sort of things, because we don't want to start any kind of electrical fires in the van. So anyways, this wire is duplex wire, which means it has both a positive and a negative strand inside the wire, and we're just going to run it in our walls to all of our areas where our electrical, our 12-volt loads will be, and they'll run back to our battery bank, which is going to be on the wheel well where you're sitting right now. So this wire is just to our fridge. It's kind of the shortest distance since our fridge is going right here, and our battery bank is going to be right next to it. So this only called for 16 gauge wire, but we sized up to 14 just for the sake of being cheaper. And then you want to leave like a foot or two of extra wire at both ends, and then we will be using tape and labeling these so that way we know what they go for. So here's what's going to our max air fan, and we're going to route it behind this board here, and we're going to have it go down the wall.
So this wire is going to our toilet fan, which is going to be somewhere right around this blue box.
Okay, so now we are going to wire the wire for our oven, which is on the driver's side of the van. Our batteries are all on the passenger side. So our oven's going to go somewhere right here. So I'm going to put the wire back through here. It's going to come all the way along this way. It'll come out right over here. This is where our bed's gonna start, where this blue line is. So it's gonna come down here and it'll go up along the beam of our bed. So if you can imagine that the beam of our bed is like right here, you're gonna put wiring right behind it on this back side of our bed frame. It'll come along here, all the way over to here. We'll put it behind this wall where these other wires we just ran are, and then it'll come back out over here where our circuit board is going to be. Okay, so we need to put some rubber grommets on these sharp edges, like this hole right there where wires are running through. The problem is that we've already routed the wires through. I've got these rubber grommets, so I can either feed them along the wire that we've already had there and then pop it into place, which sounds pretty tedious, or I can cut into the edge of this grommet and kind of put it in place, but I'd be worried about it maybe falling out of place over time. Today I am going to finish the pre-wiring in the van. We got the rest of our wire that we need ordered and it's been delivered, so I can finish running the rest of our wiring, which includes our thicker wire for our heater, as well as wires for all of our 12-volt outlets. And then we got some extension cords that we're going to use for our 120-volt outlets. Crazy. I'm gonna start with this 4-gauge cable that we're running between our alternator and our battery banks. That way we can charge our house batteries off of our car battery while we're driving. And there we go. Now that's all protected with a grommet. I've been giving a lot of thought to the way we want to route our wire to our heater, just because it's a little bit complicated with the sliding door right here. Originally, we had a couple ideas. One was to route up this side and across over and down to where our batteries will be. The problem with that is that this area is pretty narrow and it's like almost impossible to get a wire in there. We took off some of this plastic paneling and the seat belt is basically in the way. The other thought we had was to maybe somehow go along this floor and back that way, but that would require probably drilling a hole over there. And also it just seemed a little bit weird to put wiring under the floor. I don't know if wiring should be stepped on. Like the floor might put too much pressure on it. So our other idea that we've had is to route it, because it's coming under that seat, to route it kind of along this piece of the floor here towards the driver's side, back there through that plastic, and then back here along where these other wires are, and then back over to the battery. So that's what we're working with right now. So we're seeing about doing that. Another thing is, I don't know if you could tell in here, it's kind of dark, that square hole is where the wires would need to go through, and we are a little bit concerned about the edge there. So Nico is currently cutting some rubber grommets, 2 of them, and we're seeing about kind of just putting 2 of them on the edge there. And I don't know if you can tell, but there it is, with 2 half of grommets. Okay, let me explain what kind of been doing here. So this thing, we've drilled 2 holes in and put some rubber grommets on. This piece of plastic goes over here. It kind of covers this up, so the wires are gonna go back behind here and they're gonna come out this hole down here through these grommets. These 2 thick ones are going to our alternator, and this 10-gauge wire we're gonna route to our heater. So now the only thing left to do is just kind of wait for this glue to dry on those other grommets that we cut and put into place, and then we can run the wires. Hi everyone, I'm wearing a mask because I tested positive for COVID today, so it finally got me. I'm just in the van alone. Nico's doing some work outside the van. I'm just trying to finish up some wiring, so let me show you what I'm working on. These 2 wires are going to our auxiliary battery to charge our house battery from the car battery. So they just need to come here to the seat. This white one is 10-gauge wire, which we are running to where our heater is going to be. I've just ran them through the hole that you saw us put a grommet on recently. Out through here, trying to keep them out of the way of this seat belt thing. And they're going to run down here and through this plastic thing that we drilled 2 holes in and put 2 grommets on. So I'm gonna run them through that now. I've done it. These wires go down in there and they come out through here. These ones go to this. I'll probably tuck them away for now. This white one is gonna come down here. I'm probably gonna drill out a more cozy place for that wire to go, and it kind of sits underneath a subfloor. It comes along here and then pops out to where it's gonna go for our heater under the passenger seat.
Okay, just drilled a new hole. That one right there. Just gonna put some paint on it. Just both sides.
Hello from the future. I know this is kind of an abrupt jump, but there are a few different places where we didn't show us wiring to, and that's just because we had to figure some of this stuff out along the way. It was pretty obvious to wire from our battery bank to where our various appliances are, but I'm just gonna go over a few of the less obvious ones so that way you can think about this while you're doing your pre-wiring. So the first section I'll start with is our kind of control panel over here. We have this battery monitor, and this battery monitor comes with a wire that will go to your shunt, which is located near your battery and all of your other electrical components. So if you just wanted to wire that wire through your wall, we just wired it through this part of the wall down to our battery system, which is under the bed. So that's a good thing to do ahead of time. Another thing is light switches. You will want to wire a wire from your 12-volt fuse block area to your switches. In the case of this switch, which is a 3-way switch, you're also going to need to wire between this switch and the other switch, which is over here. And the reason for that is because that's how a 3-way switch works. I'm going to put up a little graphic on the screen now of how a 3-way switch shall work. Okay, here is my simplified diagram of a 3-way switch. If you don't know what a 3-way switch is, it is a switch. It's where you can turn on one switch and then turn the lights off with the other switch, so that way you can have one of your light switches near your bed, for example. That's what we have in our van. The main thing you have to know about a 3-way switch is that there are 2 positive wires between each switch. There's a couple different ways you can wire this. This is just example number 1. Also, I should point out that instead of a battery, your wires are most likely going to go to a fuse panel, a DC fuse panel like this one. But for the simplicity's sake of this example, I'm just using a battery icon. When you are pre-wiring for this particular method of wiring a 3-way switch, you're going to have primary wire and duplex wire. Primary wire means just you're having a single strand of wire. Most of the other wiring you've already done in your van will be duplex wire, which is that wire that comes with a black and a red wire in one piece of insulation. You can also buy marine grade primary wire, which I will link below. So from your positive side of your fuse box, you're going to have your positive primary wire going to your first switch. Then you're going to use duplex wire between them. Even though the colors will be different in your duplex wire, one will be red and one will be black, they operate exactly the same. There is no difference in the wire itself except for the color. If you want, you could wrap some red electrical tape around the black wire to indicate that it will be a positive wire between your 2 switches. It's also important when you're pre-wiring to label all your wires, so that way later on you know exactly what they are. So between those 2 switches is duplex wire, and then you have primary wire again from the second switch to your lights, and then primary wire from the negative part of your lights back to the negative part of your fuse block. So that's one method. This is the method we did. I thought this was easy to wrap my head around, but there is another method, which I'll show you in a second. This is just a more visual way of showing you how you will pre-wire from your fuse block, from your electrical, where your battery will live. You're going to have one primary wire to the first switch, duplex wire between the switches, primary wire to the lights, and then primary wire again back to your battery. So this is just another way of looking at this previous drawing, just maybe a little bit more simplified, if that helps your brain a little bit better. This is method number 2, which although it looks complicated, it is a little bit simpler to pre-wire, especially because you won't have to buy any primary wire. Basically, the difference between this method is that the negative wire will be just going along the same exact path as all of your positive wires, which is why it makes it easier to pre-wire. These orange little dudes are called lever nuts, and we will explain more about those in the electrical video, but they basically are ways so you can have your wires connected. So let me just get into this part. So you're using duplex and triplex wire. Your duplex wire will run from your fuse block to your first switch. Your positive wire will connect to the first switch. Your negative wire will be cut and then connected to this one, which is part of the triplex wire. You'll have triplex wire between the switches. The 2 positive wires will be between the switches, and your negative one will just skip along to another lever nut where it'll be attached then to the duplex wire to your light. And that sounds complicated in this drawing, but I've I've simplified it here again is what you need to know for pre-wiring. You will do between your fuse box and your first switch duplex wire, then between the two switches triplex wire, and then to your lights duplex wire. And that's it. You will have then pre-wired everything if you follow this basic map. Just remember that when you actually hook things up to electrical, you'll probably need to refer to this, which will make more sense when you watch our electrical video. So those are all the methods for wiring a three-way switch. If you're like me, you'll need to stare at these diagrams for a very long time until they kind of click in your brain. So I recommend just saving this video and coming back to these diagrams wherever you need to think about it. Moving on from the three-way switch. So from your switches, whether it be a light switch like this, or perhaps the switch to our propane solenoid like this one, you will need to wire from that switch to the device itself. It goes from the battery bank to the switch to the device. In the case of this one, we have most of our switches pretty close to the appliance that they will be powering. So the wire went from the battery bank to this switch and then just back down a little bit lower to underneath this cabinet, and it came back out the wall, and that's where our propane solenoid is. And in the case of the lights, we will explain our wiring for our ceiling lights in our ceiling video, because it was just easier to put the wires in place on the ceiling before putting the ceiling back up. Moving on, we have these 120 volt outlets and 12 volt outlets throughout our van. It is useful to have more than one of these per side of the van. So on this side of the van, we have 3 120 volt outlets. There's this one here on this cabinet. There's another one in this wall, which might seem a little bit redundant because they're pretty close to each other, but you know, it doesn't hurt. And then we have another one in our garage space. On this side of the van, we have 2 120 outlets. We have this one here, as well as this other one behind the driver's seat, which is accessible when we're in the front of the van working on our laptops. You'll also notice above that one, there is another 120 volt outlet. The 120 outlets are great because you can use them to charge most devices these days, including cell phones, even computers, laptops, drones, anything like that. So we have 2 12 volt outlets on either side of the bed. So for our 120 volt outlets, we used a 12 gauge extension cord. It is maybe not recommended to use a 12 volt extension cord, but we did. You could also just use 3-strand wire, which I will link in the description below. But what you want to do, if you're using the extension cord like we did, you cut off either end of it and then you strip the wires back as you would the 3-strand wire. We ran it between each of our outlets and then to our fuse box. The other thing about lights and outlets is that we ran everything in parallel. And you want to wire in parallel because the same current is flowing to each of your outlets. So if you have something plugged in to one of the currents upstream from the one downstream, you are not giving the one downstream less current. It flows to that one and it flows to the other one. It's kind of, if you imagine Christmas tree lights, if one bulb goes out, it's not going to affect the whole strand as it would if they were wired in series. It will only affect the one light bulb. A few more things over here that are smart to pre-wire is this switch, which is our WeBoost, which boosts our cell signal to the van. That just goes from our fuse panel all the way up to this area and then down to our WeBoost booster. So you'll want to think about where you want to mount that if you're going to put a WeBoost in your van. This is our inverter switch. It's just a big chunky switch that essentially came with our inverter charger from Renogy that came with a wire similar to the battery monitor that just runs back down to our inverter, which is just in the electrical area. So if you have all of your electrical things in one area, you can generally just make sure you wire those components to where your control panel is going to be, wherever you want those switches to be, down to where your electrical system will live. The last one here, this is our diesel heater control panel. It comes with a diesel heater and it also comes with a wire. So these 3 things come with wires. You don't have to worry about calculating wire gauge size for those. They will come with wires. You just might want to wire them into place while you're doing your pre-wiring. The wire comes out of the back of this control panel and down behind the blob here, down behind these plastic components to where our heater lives. underneath our passenger seat. That wire we did wire through this area, whereas the power switch to our heater wire, as you saw earlier in the video, we went all the way around this other side of the van. We did find a way to get this wire down here because it was a shorter wire, so you will have to think about wire length when it comes to your heater. So if you have your heater in a different location, your controller for it will need to be relatively close to where your heater is located.
Something that we didn't mention at all in this video is how we covered some of the wire runs in corrugated plastic to further protect the wires. We didn't use this on every wire, but we added it to every place where wires might rub against metal. We will link this product in the description down below. That brings us to the end of the video. If you made it this far, thank you, and you must be dedicated because that was a lot.
Make sure you like and subscribe to our channel. Next week we're coming out with our ceiling video, and stay tuned for our electrical video, which will go more in depth on all of the fun stuff that we began to cover in this video. See ya.
See ya.